Okay, now comes the really ugly part. It's like the good, the medium, and the ugly. Think that would be a good movie? The good, the okay, and the ugly? And that's not. Not's ugly. And not's ugly because it can't really do the job that it's supposed to do in actual mathematical logic. So let's say I put in the database a bunch of assertions. And I say, Brian likes ice cream, Brian likes pot stickers, Brian likes the Beatles, Brian likes the Kinks, Brian likes broccoli, Brian likes the zombies. Okay, that'll do. And now let me ask you, how does Brian feel about asparagus? Does Brian like asparagus? You don't know, do you? Maybe Brian likes asparagus and just hasn't bothered putting that in the database. Maybe Brian doesn't like asparagus. Suppose I ask, who likes the Beatles? How many people in here like the Beatles? Okay, I don't know most of your names, so they're not in my database. So if I ask who likes the Beatles, I'm going to get not every possible answer. So if I say who doesn't like the Beatles, and if there's no dislike information in the database, it just sits there and gives me no result at all. It doesn't tell me who doesn't like the Beatles. What we can do is say something like, who likes broccoli and doesn't like the Beatles? Because we can go through the database and get a bunch of people who like broccoli. Okay? And then for each of those persons, each person, we can say, does so-and-so like the Beatles? If it's in the database, then we say yes. If it's not in the database, we don't know for sure that they don't, but we don't know that they do, and so that would be included in the result. So as far as we know, so-and-so likes broccoli and doesn't like the Beatles. All right? The upshot of this is that not never ever generates new bindings. You never find out something you didn't know before because of not. The only thing not has the power to do is eliminate a frame, an environment, from the stream, the output stream. Okay? So not over there is a filter. It takes a frame stream, and what you get out is a subset of that frame stream. Namely, the ones for which we are not able to prove that P is true for this set of bindings. So for each frame, we run the frame through QEval with their query P, and then we say, okay, was the answer to that empty? No frames? If so, then the original frame that we started with goes in the result. If we do have a frame in the output, which means we did find a way for P to be true, then we remove that frame from the output. So anything that can make P true, we eliminate. That's what not does. So this is why it's pretty much guaranteed that if you just type at the query prompt a query that starts with not, you're not going to get any output at all. There has to be some variables bound in order for not to do anything. And there are two ways that can happen. One is that the not is in the body of a rule, and the conclusion of that rule matched your query, unified with your query, and that produced some output frames. Or the not is part of an and it's not the first clause of the and. And the first clause of the and created some bindings, some constraints on the values of variables. And then the not comes along and it says, well, okay, you said you can handle this, this, and this set of environments, but sorry, I'm rejecting this one and that one. We're only keeping this other one, namely the one for which P cannot be satisfied. Questions about that? All right. If you're confused about this, it's okay. You're just learning about it. The book talks about it at length, about the problem of not. And why, we can't just exhaustively be sure. Now, footnote. Sometimes we are dealing with a known finite universe. Okay? So, like, there's only 4 people in our universe. They're John, Paul, George, and Ringo. And we put in some assertions about them, like, John wears glasses or something. And then we can say, is P one of John, Paul, George, I'm sorry, not P, is X, person, one of John, Paul, George, and Ringo, and not such and such. So if you're in that kind of situation, then you can sort of find out all the not cases, provided that you know everything there is to know about, or everything that's interesting to know anyway, about those 4 people. That comes up sometimes in logic puzzles. So one of the things you'll see maybe in the book is trying to solve, who lives in the yellow house kind of puzzles in the query system. And you can't solve them unless you tell the query system that everybody has to live in the yellow house or the green house or the blue house or the orange house before you give it the particular clues that you have.